Good morning, everyone. Hope you all are doing good, staying at home and taking care of yourself and your family. So, this is your holiday homework, which is exercise 12.2 of Heron's formula. I have given this as a homework so that you can practice or you can do much better by seeing exercise 12.1. Only the extension part here is you will be dealing with quadrilaterals. So let's start the exercise. I'll be writing exercise. You also take a fresh page and write down exercise 12.2 and in the bracket write down holiday homework. Holiday homework. Okay. So let's start the first question. A park is in the shape of a quadrilateral ABCD. So hope you all know the meaning of a quadrilateral, any shape which has four sides. Okay. And here he has not mentioned whether it's a parallelogram, square, or rhombus, trapezium. He has just said ABCD. And what he has mentioned, one of the angle is 90 degrees and it is at C. So when we draw the diagram for it or the figure for it, we should make sure at C we should show 90 degrees and the other measurements are given. Now, when you draw the diagram, you did not to worry about 9 meters, 12 meters or something. Simply you can, there are two options. You have to keep in mind 12-meter wherever you want to show it should be the longest side and the others should be as compared to their measurements. If you don't want, then you can take your scale, take centimeter as your meters. For example, in place of 9 meters, of course meters you can't draw in your classwork, so directly you take your scale and draw 9 centimeter, 12 centimeter like this. So this is a tentative diagram here. It is given, it is not given this we have to draw, so directly I'm using the same part. Now, since it is not a definite quadrilateral matlab, it's a particular shape. For example, if we had given if the quadrilateral is in the shape of a square, we could have used S into S. Okay, if it was a rectangle, if he has mentioned or the measurements, as per the measurements, if we had seen the opposite sides are equal, then we could have said it is in the form of a rectangle, so area of the quadrilateral is equals to L into B. But when we have drawn also, it is not a particular definite shape. So what do we have to do? We have to draw an imaginary line. This dotted line is showing that divide this quadrilateral into two parts, into two different triangles. What we will do, we will find the area of one triangle, area of another triangle, then we will add them. So by this we will be getting the area of the whole quadrilateral. So we are mentioning and introducing this as let ABCD be the quadrilateral part as shown in the figure. Okay, you can draw the different diagram. You can keep this AB up and CD down. It is up to you, but this is a tentative diagram. Join BD. You have to join one diagonal. Don't join from here. One caution I am giving. Why not to join from here? Because when you join from here, it means that you are trying to divide this 90 degrees into two different parts. So it would be difficult for us to find out the diagonal AC. When we have joined BC, it is easier for us to find out BD. How to find out BD? And why to find out BD? If I want the area of the triangle ABD, how can I find? I have to use Heron's formula. And in Heron's formula, it demands all three sides, right? So I need to know BD. So how will I find my BD? Using this right angle triangle. When I'm telling right angle triangle, there is a right angle here. And in the previous videos, we all have discussed half into base into height. The formula for triangle can easily be used for right angle triangles. Remember? So using Pythagoras theorem, what is Pythagoras theorem? Hypotenuse square is equals to adjacent square and the perpendicular square. So BD square is equals to BC square plus CD square. So on substitution, I got BD is equals to 169. This power 2 we have transposed, so it will become square root. So 169 square root will be 13. So this is how we got our BD. Now all three sides of this triangle ABD is ready. Now I am saying now in ABD, AB is equals to 9 meters, BD is equals to what I got 13 meters, AD is equals to 8 meters. Now same semi-perimeter A plus B plus C by 2 Heron's formula, substitute everything in that, and this 1260 is there. He has given, you don't do it like this. Simply break this 15 into 3 5s are 15 and the 6 as 3 2s are 6. So when you're doing simple prime factorization of the basic numbers, You don't have to end up with wasting your time in multiplication, then finding LCM or something. Simply break the small composite numbers like this. 15 we can break as prime factorization, 3 5 is a 15. Okay, so like this you have to do and make paste, and you will get the area of this triangle. So how much I got? 35.5. And for this area of the triangle ABCD, BCD is half into base into height. So I got 30. So 30 plus 35.5. I am writing therefore area of quadrilateral path ABCD is equals to area of BCD plus area of ABD. So BCD I got 30 from here, and ABD is this 35.5. So when I add, I will be getting this. So this is how we have completed. The main part here and focus on is using Pythagoras theorem, substituting values, finding square roots, and finding the square roots when the numbers are given in a such a big manner, and addition and subtraction of your decimals. So make sure you do all this calculation without seeing. If you have done already in your classwork, try to practice in your rough notebooks. So this is how we have completed our question number 1. Now let's start doing question number 2. Find the area of a quadrilateral ABCD. So here very important thing we have to notice or we have to keep in mind is ABCD. He has given in an order. We also have to make the same or maintain the same order. What does it mean? For example, here AB is written. Then I should make sure from B it should go to C only. I should not take the measurement of BD. So this says that only. A, B, and after B the continuity should go to C, and after C the continuity should go to D, and from D the last two letters, the extremes, D should join to A. If you see here AB, then from B to C, then from C to D, and from D to A. This is how a complete quadrilateral in the given order is completed. Now A, B, C, D, and BD and measurements are given, and what is different he has given is AC. Now when you see AC or try to join AC, AC is nothing but acting as a diagonal in this quadrilateral. So it's the similar problem as per our previous one. So here you can say that simply you will add this area of the triangle, its area of the triangle, and get your answer. So let's start in triangle ABC. He has given triangle ABC. Consider AB square is plus BC square is equals to this, is equals to AC square. What is it doing here? Actually, it is not nowhere given that any angle is 90 degrees. But as a guess, it is trying to do 3 square plus 4 square, and it is equals to 5 square. So is it not satisfying Pythagoras theorem? If it is satisfying Pythagoras theorem, it means this is a right angle triangle and at B there is 90 degrees. See, it is one method. If you don't want to proceed with this method, you can go with a more simpler method like directly apply Heron's formula on ABC triangle. S into S minus A. In that method also you will get 6, and in this method also you will get 6. So in exam, how you should understand, if you see your previous problem, he had hidden our diagonal. He had not given the measurement. But here when he had given measurement, you can go and one step beyond and look for your Pythagoras theorem satisfying or not. If it is satisfying, that particular triangle will be acting as a right angle triangle. Okay, again I'm telling there is no compulsion that you should use Pythagoras theorem only. As all three sides are known to you, simply use Heron's formula and get your answer. Now here I can't do Pythagoras theorem. Why? 4 square plus 5 square. Always remember, to apply for Pythagoras theorem, among the three sides, one should be the longer one. Here I use longest one. Okay, 3, 4, and this is 5. Always the longest side is opposite to 90 degrees. So just to cross check whether it is really forming a 90 degrees or not, here the person have explained or tried, it's just a trial method. AB square plus BC square should be equal to hypotenuse square, and he got to know that really it is equal. Then he says that it is right angle triangle, but there is no hard and fast rule to do it again. Now when I come here and I'm thinking, "Okay, should I apply here also to check for Pythagoras theorem?" It's simply a waste of time. Why? Because before applying Pythagoras theorem, you should see all three sides. If any one of the side is the longest when you compare, then of course you can go and try for Pythagoras theorem. But here we are seeing there are two sides which are same. So from no angle it will form a right angle triangle. So directly apply your Heron's formula. You are applying Heron's formula, substituting all the values, and here when you make a pair, you got your 2 out of the root because this has cancelled the square root. But 7 is alone, 3 is alone, they are not forming any pair, they don't have, simply multiply them. 7 threes are 21. Here also you can stop. If you don't want root 21, you have to find out, then multiply that value. In exam mostly they will give you the value of the square roots. Okay, so they have given you the square root value, you have to multiply that with 2, you will get this answer. And if you see, if you all must have remembered, we do rounding of numbers. 9.16. So whenever the in decimal concept, when it crosses 5, you can round off the previous decimal to its next number. It is 1/6. So the person has rounded off to this as 9.2. Approximately what should come. It, because it is not exactly, approximately. Now what is area of quadrilateral? Whole ABCD at final. Area of this triangle plus area of this triangle, right? So here you are adding both the triangles and you are getting approximately the area of this quadrilateral ABCD could be to 15.2 centimeter square. So this is how we finish our question number 2. Now let's go to question number 3. Question number 3 is a very big problem. It has multiple problems in that. So I have skipped that. In a separate video, you can see question number 3. You can also skip in your classwork. At the end, you can do it. Now we are doing question number 4. A triangle and a parallelogram. A triangle and a parallelogram have the same base and same area. He is giving us one hint. Same base and same area. What does it mean? I'll just try to show using the pictures, using the shapes. Parallelogram. Okay. What is the speciality of a parallelogram? A parallelogram has its opposite sides parallel and they are equal. Now, I have drawn here this square or a rectangle, you can say. I'll try to use the shape. Okay, I'll just cancel this out. I will take the exact shape which is parallelogram. Okay, little same. Now, what is telling? A parallelogram and a triangle shares the same base. Basis means what? The side which lies here at the bottom on which the parallelogram is standing. If I see from this view, I will say this as the base. If you see from this view, you will say this as the base. So a triangle is there which is sharing the same base. Same base means the base of the triangle and the base of the parallelogram is same. Are you seeing here what is the condition he has given? A triangle and a parallelogram have the same base. So they are sharing the same base and same area. There are two hints they have given. If the sides of the triangle are, all three sides are given, okay, 26, 28, 30, and the parallelogram stands on the base 28. See how smartly he has given? The base of the parallelogram is 28. It means that this side of the triangle is nothing but the base of the parallelogram. So this side is 28. Find the height of the parallelogram. We have to find out height of the parallelogram. So now how to do it, what the strategy goes on. First we will find the area of the triangle. Now you will say why we should find out the area of the triangle, because he has given us the connection that this triangle area and parallelogram area is same. So what I will be doing, I will say area of the triangle is equals to area of parallelogram. Okay, then I will find out area of the triangle. Why I will find out area of the triangle? All measurements are there. Okay, if you remember what is the formula for area of a parallelogram, it is base into height, and he is asking us find out height. So base is given for parallelogram, height is not given. So what we will be doing, first we will be finding the area of the triangle. This is how we all have found this 14 14 ka plate they have made. See, here again one thing I'm telling, 14 is there. You don't need to split it into its prime factorization. Why? Because I am seeing its partner here. So there is no need only to split it into factorization. Your aim is to get a pair. You got your pair, directly make the pair. Okay. On making pairs, it will cancel out the squares and you will multiply all this line. You will get this much area is the area of the triangle. Okay. There are n number of ways how you can do it. It is not fitting properly in this. Okay. There could be n number of ways to show that they share the same base. Okay, the first diagram was also correct and this also. Only you just have to interpret your question into the field. Okay, I'm sorry it is not fitting here, or I don't know whether I'm not able to do it. Sharing the same base. There could be two diagrams, possible diagrams. So what I am doing, since it is given that area of the triangle and a parallelogram have the same base and the same area of the triangle equals to area of a parallelogram. So you got area of the triangle as 336 here meters square. Write down that is equals to base into height. Base we already know, height we want to know, transpose 28, it is in multiplication, it will go in division. On simplification, you will get h equal to 12 centimeter. So therefore, height of the parallelogram is equals to 12 centimeter. So this is how we should learn how to draw figures using the question. Second thing is that you have to decide the strategy. How will you solve the problem? What is being asked? So this is how we have completed question number 4.